Here is a line-by-line explanation for beginners. Cambridge IELTS 10 Test 3 Reading Passage 2. Autumn Leaves, Paragraph A. Original, Canadian writer J. Ingram investigates the mystery of why leaves turn red in the fall. Beginner explanation. A Canadian writer named J. Ingram tries to find out why some leaves become red in autumn. Paragraph B. Original. One of the most captivating natural events of the year in many areas throughout North America is the turning of the leaves in the fall. Explanation. In many places in North America, one of the most beautiful natural things people see each year is how the leaves change color in autumn. Original. The colors are magnificent. But the question of exactly why some trees turn yellow or orange, and others red or purple, is something which has long puzzled scientists. Explanation. The colors are amazing, but scientists have been confused for a long time about why some trees turn yellow or orange and others turn red or purple. Paragraph C. Original. Summer leaves are green because they are full of chlorophyll. The molecule that captures sunlight converts that energy into new building materials for the tree. Explanation. Leaves are green in summer because they have a chemical called chlorophyll. Chlorophyll catches sunlight and helps the tree make food. Original. As fall approaches in the northern hemisphere, the amount of solar energy available declines considerably. Explanation. In autumn, in the northern part of the world, there is much less sunlight. Original. For many trees, evergreen conifers being an exception, the best strategy is to abandon photosynthesis until the spring. Explanation. Most trees, except evergreen trees like pine, stop making food from sunlight, photosynthesis, until spring. Original. So rather than maintaining the now redundant leaves throughout the winter, the tree saves its precious resources and discards them. Explanation. Instead of keeping the useless leaves, the tree drops them to save energy and nutrients. Original. But before letting its leaves go, the tree dismantles their chlorophyll molecules and ships their valuable nitrogen back into the twigs. Explanation. Before the tree drops its leaves, it breaks down the chlorophyll and sends the important nitrogen back into the branches. Original. As chlorophyll is depleted, other colors that have been dominated by it throughout the summer begin to be revealed. Explanation. When the green chlorophyll fades away, the other colors that were hidden during summer start to show. Original. This unmasking explains the autumn colors of yellow and orange, but not the brilliant reds and purples of trees such as the maple or sumac. Explanation. This explains why some leaves turn yellow or orange, but it doesn't explain why some turn red or purple, like maple trees. Paragraph D. Original. The source of the red is widely known. It is created by anthocyanins, water-soluble plant pigments reflecting the red to blue range of the visible spectrum. Explanation. Scientists know that the red color comes from a substance called anthocyanins, which are plant chemicals that dissolve in water and show red to blue colors. Original. They belong to a class of sugar-based chemical compounds also known as flavonoids. Explanation. These anthocyanins are part of a group of sugar-like chemicals called flavonoids. Original. What's puzzling is that anthocyanins are actually newly minted, made in the leaves at the same time as the tree is preparing to drop them. Explanation. What's strange is that the tree makes these red chemicals while it's getting ready to drop the leaves. Original. But it is hard to make sense of the manufacture of anthocyanins. Why should a tree bother making new chemicals in its leaves when it's already scrambling to withdraw and preserve the ones already there? Explanation. It seems confusing. Why would a tree make new red chemicals when it's trying to save and take back old ones? Paragraph E. Original. Some theories about anthocyanins have argued that they might act as a chemical defense against attacks by insects or fungi. Explanation: some scientists think the red color might help protect leaves from insects or fungi, mushrooms or mold. Original: or that they might attract fruit-eating birds or increase a leaf's tolerance to freezing. Explanation: or maybe the red color attracts birds or helps the leaf survive cold weather. Original: however, there are problems with each of these theories. Explanation: but each of these ideas has problems. Original: including the fact that leaves are red for such a relatively short period. Explanation: for example, the red color only lasts for a short time. Original: the expense of energy needed to manufacture the anthocyanins would outweigh any antifungal or anti-herbivore activity achieved. Explanation: making the red color takes a lot of energy, which might not be worth the small protection it gives. Paragraph F. Original: it has also been proposed that trees may produce vivid red colors to convince herbivorous insects that they are healthy and robust. Explanation: another idea is that trees turn red to trick insects into thinking the tree is strong and healthy. Original: if insects paid attention to such advertisements, they might be prompted to lay their eggs on a duller, and presumably less resistant host. Explanation: if insects believed the red color meant the tree was strong, they might choose a weaker tree, less colorful, to lay their eggs. Original: the flaw in this theory lies in the lack of proof to support it. Explanation: the problem with this idea is that there is no real proof. Original: no one has as yet ascertained whether more robust trees sport the brightest leaves. Explanation: no one has shown that stronger trees have the brightest red leaves. Original: or whether insects make choices according to color intensity. Explanation: or that insects choose trees based on how red the leaves are. Paragraph G. Original: perhaps the most plausible suggestion is the theory known as the light screen hypothesis. Explanation: the most believable idea is the light screen theory. Original: the idea behind this hypothesis is that the red pigment is made in autumn leaves to protect chlorophyll. Explanation: it says the red color protects the green chlorophyll. Original: why protect chlorophyll at a time when the tree is breaking it down? Explanation: but why protect something the tree is already breaking down? Paragraph H. Original: chlorophyll can sometimes be overwhelmed by sunlight, especially in situations of drought, low temperatures, or nutrient deficiency. Explanation: chlorophyll works well but can be damaged by too much sunlight, especially during dry weather, cold, or lack of nutrients. Original: the problem of oversensitivity to light is even more acute in the fall. Explanation: in autumn, chlorophyll becomes even more sensitive to sunlight. Original: the leaf is busy preparing for winter by dismantling its internal machinery. Explanation: the leaf is shutting down its systems to get ready for winter. Original: the energy absorbed is not immediately channeled into useful products and processes. Explanation: the sunlight taken in is not used properly, as it is during summer. Original: the weakened fall leaf then becomes vulnerable to the highly destructive effects of the oxygen created by the excited chlorophyll molecules. Explanation: so the weak autumn leaf made by the overactive chlorophyll. Paragraph I. Original: even if you had never suspected that this is what was going on when leaves turn red, there are clues out there. Explanation: you may not have known all this before, but there are hints that show it's true. Original: one is straightforward. On many trees, The leaves that are the reddest are those on the side of the tree which gets most sun. Explanation. For example, the reddest leaves are often on the sunny side of a tree. Original. Not only that, but the red is brighter on the upper side of the leaf. Explanation. Also, the top of the leaf is usually more red. Original. It has also been recognized for decades that the best conditions for intense red colors are dry, sunny days and cool nights. Explanation. Scientists have known for years that the best red colors happen in dry, sunny days and cool nights. Original. Conditions that nicely match those that make leaves susceptible to excess light. Explanation. These are the same conditions that make leaves more sensitive to sunlight. Original. And finally, trees such as maples usually get much redder the more north you travel in the northern hemisphere. Explanation. Also, the further north you go, the redder trees like maples become. Original. It's colder there. They're more stressed. Their chlorophyll is more sensitive and it needs more sunblock. Explanation. That's because it's colder in the north, so the trees are more stressed, and their chlorophyll needs more protection, like sunblock. Paragraph J. Original. What is still not fully understood, however, is why some trees resort to producing red pigments while others don't bother. Explanation. Scientists still don't fully understand why some trees make red pigments and others don't. Original. And simply reveal their orange or yellow hues. Explanation. Some trees just show their orange or yellow colors. Original. Do these trees have other means at their disposal to prevent overexposure to light in autumn? Explanation. Maybe these trees have other ways to protect themselves from too much sunlight. Original. Their story, though not as spectacular to the eye, will surely turn out to be as subtle and as complex. Explanation. Even if their colors are not as bright, their story is probably just as interesting and complicated.